All right, we'll continue evaluating limits graphically and numerically. And let's start with this graph. Pause the video and write down the value of each of these limits. So this says go to -1 from the left. So here's -1. Let's approach from the left, and we are going towards a y value of 2. Let's approach -1 from the right. So -1, approach from the right, and we're going to a y value of 1. And this says go to -1 from both sides, but we saw that we go to different numbers. So that limit does not exist. Approach 1 from both sides. So here's 1. From both sides, the y values are approaching 1, y equals 1, even though the function value is at 2, the limit is at 1. And let's go to 2 from both sides. Going to 2 from both sides, the graph is going to positive infinity from both sides, so the limit is positive infinity. And this says go to positive infinity, go way out to the right, and the y value is approaching 0. This says go to the left, follow the graph, and the y value is going to infinity. And here we'll just look at this numerically. So we're approaching 9, but only from the right. So in the table we would only need to use values over here. And we just use the calculator, that's undefined, and here we have and we can see that it's approaching -1.67 approximately. So we'd say the limit is -1.67. And pause the video and try that one. Going to 0 from the right, so we only need to look at numbers on the right. And when we substitute 0, we get 3. When we substitute 0.01, 3.12. When you put in a 0.1, you get 3.5162. And we want to know what y value is it approaching. It's approaching 3. So the limit is x goes to 0 from the right. Equals 3. And also notice that we can't go to 0 from the left because then we would have an imaginary number there. So let's go to 0 from the left. Pause the video and try this one. Make sure your calculator is in radian mode. And if you chose different numbers, that's fine. They just have to get close to 0. Here we have 0.56238. And here we have 0.86232, negative 0.8391. So we're getting really close to 0. There's a negative number. It goes up to a positive number, comes back down to a lower positive number. And we can't see that the y value is approaching a number because we're really getting close and it's still jumping around a lot. So this turns out, if we checked more x values, we'd see that it just continues to jump around, and the graph is one that oscillates. And so you'd see, if you graphed it, it just keeps doing this and then does that. And that's the limit does not exist due to oscillation. The limit, as x goes to 0, from the left, does not exist due to oscillation. Oscillation is when it goes back and forth. All right, pause the video and try that one. So we need to get to 5 from both sides. And from the left, we could choose numbers like these. From the right, choose those. And then we have to substitute each of these into that. When you do that in the calculator, make sure there's a parentheses in the numerator and denominator. Well, here just denominator. This is undefined. And so this number, as we go this way, these y values are getting large, so it looks like it's going to infinity. Same thing over here. So we'll look at the graph. And the graph does this. So we can say that the limit as x goes to 5 is infinity, because they're both going to infinity. Alright, pause the video and try that one. We're going to -3. So to the right, we'll have -2.99, -2.9, -3.01, -3.1. When you put a -3 in there, it's undefined. And we get these numbers, these y values. So it looks like that might be going to infinity, and that might be going to -infinity. So here we see the limit does not exist. This limit does not exist because it has to go to the same place from both sides. And if we looked at a graph, there's the vertical asymptote at -3, and this ends up having a slant asymptote. So it looks something like that. The limit of the function as x goes to -3 does not exist because it goes to two different values. So here we're going to -infinity, and that just, it changes where we look on the graph, and it also changes which numbers we use in the table. If we're going to -infinity, we just want to choose some large numbers. We can see what's happening here at, when we substitute a 0, we get -13/8. Here's at -1, we get -17/6, 4.4167, and 2.0146. So we want to know what's happening to the y value as the x value goes to -infinity. And if we kept on going with larger x values, we'd see that we just keep getting closer to 2. The limit as x goes to -infinity of the function is 2, and that appears in the graph as a horizontal asymptote at 2, and the vertical asymptote is at -4. So we see this happening and that happening. All right. Pause the video and try that one. X is going to +infinity, so we will choose numbers that are getting larger to the right. And when we substitute 0, it's undefined. When you put in a 1, we have 1 minus 3 is -2. And with these numbers, we keep getting -2.9999, and it just keeps having more and more 9s. So we're just going to say that's approximately -3, approximately -3. And we just see that it approaches the asymptote, the horizontal asymptote at -3 pretty quickly. So we can say the limit of the function as x goes to infinity is -3. Horizontal asymptote's at 0, and we're just looking at this part of the graph that's going to the right, and the y value is approaching -3. And we'll stop there.